So everyone, thank you for coming. I'm Andy, and I'll be introducing Lauren. It's a particular pleasure of mine because Lauren was one of my PhD students many years ago. And I taught her all the wrong things she knows. And she's steadily winnowed away at those and become learned many right things. So after working with me and Danielle Navarro and Adelaide, Lauren went to do a postdoc at Columbia University, where she worked with Andrew Gelman. And her interest has always, even, even as a PhD student and even as an undergrad, been very interested in sort of statistical and measurement issues, as originally in psychology, and now I think much more broadly in the social sciences in general. So for her PhD, she did a lot of sort of different kinds of statistical issues that crop up in psychology. So looking at things like contamination, or the kinds of inferences you can make when you have really skewed distributions and so forth. And since working, going to Columbia, she did a lot of work in survey statistics, particularly sort of the naughty problem, which I think she'll be talking about today, about how you generalize from really non-representative data, which I think is a general issue we all struggle with a lot about. And Lauren has a pretty unique background of knowing a lot about the sort of psychology and cognitive science, but also being a very, stats maven. So I'm really eager to hear you solve all our problems, Lauren. I'll turn it over to you now, and let's welcome Lauren. Yeah.
No pressure at all. Yeah, let me share my screen. There you go. Should be able to see that. And then if I click play, it kind of pops up, right? Yeah. So I won't be able to see. I might be able to do it, but I don't know how to make it so that I can see your comments. So if you have any questions, just like yell out. That's totally cool. Sorry. You'd think after all this time with Zoom, we'd be better with it, but I'm not. All right, so I'll get started. So this is joint work with Andrew Gelman, and I sort of started it in 2017 when I first started my postdoc with Andrew, and then it just got accepted at PsycMethods like 2 days ago. So this is sort of the work that I'll be talking about, but also like I'm still working on these ideas, and I think a lot of them are quite open. So these are also reflections of collaborations with Dan Simpson and Alex Gao, Alan Riddle, and a bunch of other people who sort of have great ideas on these things. So this is the paper that is mainly what I'll be talking about. There's an archive copy online. So Andy already did a great introduction for me, so I won't go into this too much, but now I'm a lecturer at Monash Econometrics and Business Statistics, and I will get used to saying that smoothly. And so really this work came about, so I spent a lot of my PhD sort of thinking about heterogeneity and how we measure things and how we understand things and how different samples can really change what we observe. And so then when I went to postdoc with Andrew, we started doing a lot more survey statistics, and it suddenly kind of clicked that these problems are kind of the problems that survey statisticians have been working on for quite a while. And so if you don't mind, I have a little example to sort of talk about what I mean. So this is my population. It's made of red people and blue people. And some of the blue people like cats, and a lot of the red people like cats. And so overall, 50% of the population likes cats, right? But within each group, there's a different proportion. So let's say I took a sample. And so I took a sample, I oversampled blue people, right? And I asked them all if they like cats, and they all responded very friendly and helpfully that they like cats. But if I tried to estimate the proportion of the population who like cats from that, it'll be quite a bit off. And I think this is actually just the crux, right? Like, surveys are almost always non-representative. Now, sometimes that's by design. Probabilistic sampling, cluster-based sampling, these designs are designed to help us get efficiency, but they also involve sampling, probabilistically sampling with different probabilities, but often it happens through non-response as well. So you have differential non-response across ages, between genders, economic status, socioeconomic status, but also it happens through necessity, so convenience or snowball sampling. So we call these non-probability samples in the survey literature. In psychology, this is how we get, you know, a good portion of our participants, I think. And so I was really thinking about how these things sort of play together, right? So if we have a non-probability sample, so what can we do? Well, I think to do this, you have to kind of look back and say, well, how did we used to do it? What's the current best practice? So traditionally, if you have a survey design, you're sampling probabilistically, you kind of create this vector of weights. So this is our sample again, and we give them a weight. And so we say each blue person represents 4 blue people in the population, and each red person represents 12 red people in the population. And then because weights are a little funny and are all a bit relative, we can actually make that 1 and 3 because it looks nicer on the screen when I make 3 of them. And so then if we try and do a weighted estimate of the proportion of people who like cats, we'll find that we get 12 and 12, and then it'll be 50%, right? We're back to where we were before. So these are weights. I've created them, I use them, they're wonderful, but they're also a little bit challenging. And I think they're challenging because people don't respond, right? So if we know the probability of inclusion for every single person, it's not too hard to make weights, and they work the way weights you'd expect. But, you know, more and more when we call people to take part in surveys on the phone, they don't respond, or they don't want to respond, or they think we're spam. And so the response rates are really dropping, right? And they're dropping and dropping and dropping. And so now non-response is kind of carrying a lot of the challenges of non-representation. And so they can be really challenging to make. And I guess this is a separate issue, but using weights can also be quite challenging too when you're going beyond sort of standard estimates of mean and things. So in response to that, in '97, Gelman and Little sort of proposed this method that sort of builds on a lot of older methods like the Fay-Harriott method and post-stratification more generally, this idea called multi-level regression and post-stratification. And it's gained a lot of traction. It's often called Mr. P or MRP. And especially within the political sciences, it's very, very, very popular. And so now, the way I think of it, now instead of modeling how many people these people represent in the population, now we're modeling the outcome in terms of demographics. So if you think about this in terms of our red and blue sample, the probability that you like cats, given that you're a blue person, is 25%. The probability that you like cats, given that you're a red person, is 75%, right? So before we were thinking about how many multiples of these people do I have to take to make them the population. Now we're just thinking about the outcome in our sample. And then we say, well, we have 36 blue people, so we'd expect about 25% of them to like cats. And we have about 36 red people, so we'd expect about 75% of them to like cats in the population, you know, as estimated by our sample. So that would be about 9 and 27. We add those together, so we end up with half the population who like cats, right? It's another way of getting this sort of estimate at the population level. So there we go. And so that really, that's kind of the whole idea. It's not super complicated, but it's interesting to think about how it plays out when it's different and when it's the same. And so just to put a little bit of notation behind it, you start off, it's a 2-stage process, multi-level regression and post-stratification. Basically, a lot of the research we do is either taking step 1, which is the multi-level regression bit, otherwise known as a mixed effects model in psychology, and subbing in different models for it, or taking the post-stratification part and, you know, doing a few things there. But you start out with a multi-level regression, a mixed effects model. But kind of importantly, we define a set of discrete covariates, and they have to be discrete. So this is like, instead of age, we use age group. We could do education level as in brackets. We could do race ethnicity. It's quite common in the US. And we say, well, we know X in the sample because we've measured it. And in the population, we know it from the census. We know the counts. And I'll go into that a little bit more in a minute. And then we have this Y. And Y is the thing that we observe in the sample, but we want to estimate in the population. So before it was whether you like cats or not, right? Or the proportion of people who like cats. So if we're just thinking about a binary outcome, and we'll start there because that's often the example people do with MRP, then we really just model it, right? So we model the outcome, whether you like cats or not, given some fixed effects, and we use fixed effects for really binary response variables, things like, honestly, sex. Political science still does measure sex as male or female a lot of the time. And then we have these varying effects. Now, the notation's a little bit weird for this, but basically you can think of having a random effect for each demographic. So you'd have a random effect for age group, and a random effect for education level, and a random effect for whatever else, right? And importantly, those random effects mean that we're partially pooling. So I have a mu here. This is one way of writing it. You can also write it 0 and have an intercept in the model, right? And it works out the same. And one of the nice things about partial pooling is it helps us to regularize. So what do I mean by this? So if you think of it, say you just have a model and you're trying to predict based on like school, right? Based on school. So if you put school into the model as a fixed effects, what we do is we dummy code it, right? And we estimate a parameter for each school, right? And that's kind of no pooling. Like, we're not sharing any information between the schools. We're just estimating a different parameter for each school, right? The other side of that is to just do an intercept only model, right? And that's kind of like full pooling. Every school ends up being estimated with the same parameter. Partial pooling is kind of somewhere in the middle, right? You're kind of sharing a little bit of information across schools, but you're not saying they're all the same either, right? And that sigma in the, that sigma k, what that is it kind of controls how much you're sharing information. And it turns out this is really pretty cool, because partial pooling helps us to regularize our estimates where we have small cell sizes. So we have not very much data to stop us from overfitting. And that gives us better prediction. But it's also particularly useful for survey data because it's almost always sparse, right? It's sparse due to the population because there are just rare groups in the population, but it's also sparse due to non-response patterns. And sometimes they play off of each other too, right? So rarer people in the population, for whatever reason, are less likely to respond to surveys. So that's just the multi-level step. And you're familiar with this. We do multi-level regression, we do mixed effects models all the time in psychology. This is the post-stratification step, the next step. And as I said before, it's really any type of model. So we have papers where we've done spatial effects instead of a random effect, or AR1 or random walks instead of a random effect. But it's really any sort of regularization model. So there's a version of this where they use BART, which is a type of regression tree that sort of regularizes. They've used stacking, which is kind of, again, stacking different types of regularization techniques. But then you have this post-stratification. And so really, when I think about post-stratification, I really think of it as predicting into the population, right? So you have this sort of understanding of how your demographics relate to your outcomes, and then you're trying to predict it up into the population. And that sounds kind of easy. We do prediction quite a bit in statistics and psychology all over the place. But it turns out to be a little tricky because the population is very, very big. And so even if we knew data from every single person in the population through a census, It turns out that it's quite big and it will crash R from experience. So what we do instead is we create a post-stratification matrix. And what that does is it describes all the possible combinations of X, of your demographics, and the number observed in each cell. So if X1 was age group, X2 was gender, X3 was education level, we would have the number of people who are in the 18 to 25 bracket who are female, who haven't completed high school, the number of people who are in the 18 to 25 bracket who are female, who have completed a bachelor's, the number of people in the 18 to 25 who are female who've completed a bachelor's plus, and so on and so on, right? And we get this from the census. In the US, we use the American Community Survey because the census is decennial, but in Australia, we have 4 yearly census, so it's a little bit easier. Okay, so now we've sort of summarized the population information. What we do then is we use our model to estimate the probability of our outcome. Remember, we're still thinking binary because it kind of works nice when you're putting it on a screen. The probability of our outcome for every cell, right? Which we can do, and if we're Bayesian, we can have a posterior for it, so we have full uncertainty. And then we aggregate it, right? And what I mean is I say, well, if, n1 times the probability that y equals 1 for n1, n2 times the probability that y equals 1 for n2 for that cell, n3 times its corresponding probability, and I add them all up, and then I divide it by the total. So that's like the weighted mean, right? And then you have a population estimate. So maybe that sounds simple, maybe that's a little bit confusing. I guess I can pause and see if anyone has any questions. I genuinely don't have the chat up. No?
There's no questions in the chat, Lauren. I'll keep it for you.
Beautiful, thank you. Okay, so that's kind of MRP in a very, very quick primer. But when we think about psychology, it kind of makes sense, right? Like we have samples, they're not representative, but our outcomes aren't really binary and our samples are kind of very unrepresentative. So how do we kind of connect these two ideas up? I couldn't have a talk about cats without cats. So what about these sort of very unrepresentative samples that we have in psychology? And I say this as a psychologist, like I know we have unrepresentative samples and I don't think it's always a bad thing. I'm not saying that it is. So we can start by thinking about who takes part in psychological research, right? We have undergraduate samples and we have our Amazon Mechanical Turk, prolific academic, crowdflower samples, which are generally a sort of wider group of people. Generally, we really do have weird samples, and I know there's a big push to sort of move away from that, but this is mostly westernized, educated from industrialized, rich and democratic countries. But there's like definitely research, where we have like community samples and people use sampling schemes as well. So this isn't like a general thing, it's just the most common. And then there's this question of who do we want to talk about? And so you can kind of break it up. So maybe we want to talk about the experiences of particular groups of people. Maybe we want to talk about the experience of all people ever, right? Generally, I don't think this is true because I think psychology is very understanding that we have a sociological component to our cognition as well. And so you can't really ever talk about all people ever, right? Because society changes over time. And maybe especially, I think in this group, we want to talk about the impact of careful manipulations and interventions. We want to talk about their effect. And maybe some other things. I'm not sure. It's a big field, right? And then the question that I always ask myself with all of this research is kind of, do the people we want to talk about take part in our studies? And it obviously really depends on the population and the study and who we want to talk about. But you can ask yourself this with survey research as well, and I quite often do. For example, if you're doing a phone survey, which is generally thought to be quite good practice, the reality is like I would never take part because I hate talking on the phone and I never pick up my phone anyway. And so all of a sudden, you know for sure that there's at least one person who's not responding, but most likely there's a whole bunch of people who aren't responding. But it doesn't always matter. And like, this is a really tricky idea. So say we have our population again, the red and the blue people, but now some of them wear hats. So they're people in hats who may or may not like cats. And importantly, and I'm not sure if you can tell this from the picture, but I'll just point it out, having a hat doesn't impact whether you like a cat or not. It's just the color. So if I take a sample and I've oversampled people who wear hats, but wearing a hat doesn't relate to liking cats, then oversampling people who wear hats doesn't really impact our estimates of folks who like cats, right? However, if we oversample people, folks who are red, and being red does relate to liking cats, and we've already seen it does, then oversampling people who are red does impact our estimates of folks who like cats, right? So you have to both be unrepresentative on a specific parameter or demographic, and that demographic has to be important for whatever you're measuring, right? Right. So I guess more broadly, what I'm trying to say is I don't actually think samples are ever fully representative on every possible demographic or thing that you could imagine to compare them on, because that's just not the way life works or the way people work. But it doesn't actually matter all of the time, right? But thinking really hard about when it does matter and when it doesn't matter is hard and really important. It's what I'm really excited about doing. So that's kind of an overview of the methods. And so one of the nice things that we do in our paper is kind of go through some examples where we think really specifically about psychology and try and find examples where we might want to use this method and actually be able to use it.
Hi, Lauren.
Hi.
Before you get into the example, I think Christina has a question. I'll go to her.
Hi.
You're on mute, Christina. You're
Still on mute, but
You're on mute, yeah.
Okay, yeah, thank you. I made the classic error. Can you tell me how you figure out whether the two things are based on conditional probability or not? Because that's what I don't understand in that last slide. So how do you know that two things are intrinsically related? So being in one category is related to being in the other category versus one of independence, which was on the right-hand side of the slide?
Yeah, it's an excellent question. So mathematically, there aren't, to my knowledge, really good methods of knowing this yet. We're working on ways of understanding this a bit better. I think as experimenters, we actually carry a lot of this information around with us in our heads, right? And I don't quite know where it comes from. I think part of it is experience and part of it is the literature and looking at individual differences studies. And part of it is just kind of intuitive, it makes sense. So I'm gonna, at the end, I have a couple of examples of studies that I'm actually designing where we've sort of tried to think about this.
Okay, I've kind of preempted that then. I'll probably
No, it's an excellent question, and I would love to have an answer for you. Maybe 5 years we'll have better methods, but
no, that's okay. I just thought I'd missed something crucial and then had like a bit of a brain freeze or something, which
No,
yeah,
you're
thank
good.
you.
No, it's a great question.
Lauren, can I quickly ask, I was wondering about the possibility of actually modeling the selection bias, like with some kind of causal approach. Is that ever possible for these sorts of applications?
Yes, so this is really an excellent point. This actually ties in really closely to causal inference, especially when you start thinking about modeling treatment effects. So one aspect of research that we're looking at is comparing causal methods like BART, which is the regression tree sort of family of causal inference, to methods like MRP, which is kind of like, it's funny that they're so similar, right? In fact, causal inference and this sort of survey research and also imputation, if you frame it in a predictive framework, they end up being very similar, right? You model something, you try and predict something you haven't observed. They all end up having the same sort of methodology, which is really nice because it means we can look at these different fields and look at diagnostics that are useful and look at tools that are useful and try and apply them in different ways. Does that sort of answer your question?
Yeah, thank you.
Yeah. Okay, so this is my first example. This is real data. Not data that I collected, but real data that exists in the world. So respondents took part in a survey that collected sort of basic demographics and some responses to a set of questions designed to measure Goldberg's 1992 5-factor model of personality. So from my undergrad days, I would call this the ocean factor, the ocean model, right? So each factor was measured with 10 items. Some were reverse scored that we re-reversed. And the survey was completed online, completely anonymous, and the data from respondents was just released as open data. So there were respondents from all over the world. We subsetted down to the US respondents, which was, I think, confirmed through IP by the folks who did the study. We're not really sure how they came to be in the study. I would guess that some of them are undergraduates because of the age of the respondents, which is very, very young. But we don't really know, right? It is mostly female, there's 34% male. And, you know, in the 13 to 25 age group, it's 60% of the sample, but it's only 20% in the ACS. They did measure race ethnicity, but they coded it using levels that are kind of the international standard, and we weren't quite sure how to map them to the US standard levels. So we didn't use that in our analysis because we wanted, part of this paper was designed to be as a tutorial. We wanted it to be fairly simple. And they didn't collect education data, which I'm a little disappointed about. Okay, so the sample, hopefully, I've convinced you, is not representative. The question is that an issue, right? So if we expect the variables we know are unrepresentative to be related to the outcome, then that's an issue, right? And so we have some evidence for both gender and age effects, that there are different effects on personality facets. Hopefully that made sense. I got there in the end. So ideally, I think we would have adjusted for education as well, but that wasn't really measured. Okay. Oops, I did clear this up. So how do we use MRP for this? Well, what we did was we modeled each scale outcome by gender, male or female. They actually measured more inclusively. They had male, female, other. The US Census, unfortunately, only measures male, female. So we subsetted down to male, female because it was simplest and it was meant to be a bit of a tutorial. But we're currently running a paper on a better way of doing that and some of the alternatives. And also age group. So this is the BRMS code. If you're familiar with LME4, practically the same. The only difference is BRMS lets you do truncated regression, which is really nice. And we did a model for each subscale, right? Adjusting for those demographic variables. So now we have this model, and it's kind of important that we use a truncated regression because we're going to do predictions. And if you just use a normal linear, assume a normal linear outcome, what you end up doing is predicting values that are outside of the scale, and it's kind of not clear what that means. Okay, so now if we were doing MRP and we were political scientists, we would take a summary statistic of our distribution and we would estimate it in a post-stratification table, and then I would summarize over the post-stratification table, right? And most of the time this is probability of Hillary or Trump, or, you know, Biden or Trump, or whoever's in the election this time around. But we're not interested in just the mean or a summary statistic. Here we were sort of thinking about whether we could do a norming curve. And so here we're interested in a distribution, right? And I've already sort of said that we can't hold the whole population in memory in R because it will crash. Unfortunately, I've crashed R many a time from this. So what we did was we drew random samples from the population and predicted for each hypothetical individual in the sample. So you can think of this as, this is like ideal sampling, right? If you have proper random sampling, what would it look like? And then we plotted the distribution of these to simulate norming curves. And also we did the same, but for our sample, just to give it an indication of uncertainty or model misspecification. Okay, so what does that look like? So here's extroversion. The histogram is the actual data we observe. It's really nice, right? Like nice, centered at 30. It's a great, very well calibrated scale. And then this is the norming curve. We're just predicting with the sample. So if we used our sample as a norming curve, this is kind of what we get. There's multiple lines because we use multiple posterior estimates to do that, just to give you a bit of an estimate of uncertainty. And this, the red, represents the norming curve for our simulated random sample. Now, you might look at that and say, hey, it's not that different, Lauren. Like, what's the point? Right, it's not that different for this one. But if we look at conscientiousness, so this is the distribution of scores in conscientiousness in our sample. This is the norming curve if we just used our model to predict into the sample. And this is for our population, for our simulated random sample from the population. And it's quite a bit different, like not a lot, it's not wildly different, but we wouldn't expect it to be wildly different. But it is a bit different, right? Really, when you consider that we have like 8,500 people. And if you're curious, we did this for all of the scales, and some of them are like extroversion that they don't really make a huge difference. And others like neuroticism makes quite a difference. And this kind of makes sense too, right? Like neuroticism tends to decrease. You tend to get less severe in neuroticism as you get older. And then our sample was very young, right? So it kind of makes sense that the curve gets pulled down a bit. All right, hopefully that makes sense. We did have limitations. Partly was, the limitations were because we wanted it to be a tutorial and we actually put it into like psych methods call for tutorials. And so we wanted to try and keep it simple so that it was easier to follow along. So we adjusted the gender as a male, female, but obviously they measured other and we want to include other, but we're just limited by the US census definitions. So we're working on a paper that sort of goes through all of the many options you could have in that case and what you should do and what is ethical to do and all of those things. We didn't adjust for education level, which I think we should have, and if you were doing this in a real, for a real norming curve, you probably should, or a race ethnicity. Okay, so we submitted this for review and we got wonderful reviews back. It's actually been a really fun review process, but one thing that kind of was difficult to see was, well, how does this really play out when you start thinking about like experimental psychology, right? Which was how I was trained, and he did a wonderful job training me in experimental psychology, and really I think is a lot of psychology, right? So this is what we did. We looked at a simulated experiment. And we basically just chose a simulated experiment because it was easier to manipulate things and we could kind of control things, and it's a little less common to see data of the form that we wanted. So then we started thinking about what does heterogeneity mean in an experimental context, right? And it's interesting, a lot of the people writing about it will say, randomization, no worries, mate. Like, you're laughing, it's gonna be great. But unfortunately, if the sample isn't representative of the population and there's heterogeneity expected in effect, then that can be then you can have an issue estimating the effect, even with randomization, which is kind of crazy. So we simulated kind of a hypothetical sample, which was just an undergraduate sample at a single university. We simulated sampling 300 students defined by 2 demographics, major, so we had 1 of 5, and gender. And because this was a simulated example, the other nice thing was that we could model gender as like 3 categories, which is what we wanted to do originally. And then we propose, this is all simulated data, just to be very, very clear, a mass anxiety intervention that is randomly allocated to each participant, right? Simple randomized control trial. And what we hypothesized was that the intervention effects differ by student major. So liberal arts students would have a larger effect for the intervention than engineering students. And you can imagine this happening. This is why we tried to give labels to this. The sample also contains more liberal arts students. And then the other thing we did, just to make life really difficult for ourselves, we used a truncated outcome scale because it's more realistic. All of our scales are, well, not all, but a good portion of our scales are truncated. But they're also much harder to deal with. Okay, so how would we use MRP for this, right? This is not a political survey where we're asking whether you'll vote for Hillary or Trump, right? Now we have two outcomes, and how do we deal with that, right? We have mass anxiety before intervention, we have mass anxiety after intervention, and then we have whether the intervention is either treatment or control, right? And we're kind of interested in the pre-post difference given treatment. So I should note, if we just simulated the data as normally distributed with no bounds, we could just take the two and model the difference and we'd be laughing. Now, we didn't do that, but we could have, and that would have been an easier option, right? Instead, because we have a truncated outcome, we wanted to use truncated regressions, and you can't just subtract one from the other and get a truncated regression back. It's just quite how it works. So we often do this in psychology. You've probably done this in your research as well. Sometimes it's a fine approximation, but unfortunately, when it came to doing predictions, we ended up predicting a lot of values that were outside of the scale values, and it just wasn't clear what we should do with that in an MRP context or just sort of more broadly. So instead, we have this more complex approach. We have the time one model where we model mass anxiety by demographics, so by gender and major. So notice that now we have a random effect for gender. The reason for that is now we have 3 levels of gender, so we can at least start to estimate that variance term. And also one of them is quite small in the sample and also the population. So it's useful to be able to regularize it. And then we have our time 2 model, which is mass anxiety at the second time, modeled by mass anxiety at the first time, with a treatment effect for each gender and each major, right? Okay, so, sorry, I should stop going back. So what does that look like? Well, this plot's a little hard to read, but what the box and whisker plots are our estimates for the undergraduate population, that's the red, and the sample using MRP. So the box plot is MRP using the sample, and then the undergraduate population is like the truth, right? And here we could actually just estimate the undergraduate population because we simulated a lot, it wasn't a very big population. And what you can see is the black box plot is closer to the red than the scatter of data, particularly for the treatment. And the reason for that is the scatter of data is the real data that we observed, and the MRP estimate kind of pulls it down a bit. Another thing that you might be interested in doing is not just estimating for a new population or the whole population at the university, but you might be interested in saying, well, what if we have a new sample and the sample is now mostly engineering students, right? Could we estimate the effect that we would observe in sample 2, our mostly engineering student sample, to our sample that we could observe in sample 1, which is mostly liberal arts students with a few engineering students struck in. And so blue is the estimate for just sample 2, red, the estimate for just sample 1, and black is the estimate for sample 2 using only sample 1. And the scatter of dots is the true data. And what you can see is that the black estimates is much closer to the blue than the red, which is good. And then you might have this like third question, which we didn't go into in the paper, was what if you want to post-stratify to a new university, right? We've observed one university, we've kind of looked at predicting with different samples that have different demographics, but all within the same university. What if you want to predict to a new university, right? Well, you kind of need strong assumptions, right? You need to assume that the students at University A are the same as the students at University B, right? Better yet, we could sample from multiple universities in the first place, and then we could model university-wise heterogeneity directly. Okay, So they're the two examples that I talked about in the paper. I don't do a lot of experimental work, but I do tend to work with people who are doing experimental work. I'm going to help with the design and some of the methods. So I wanted to talk you through two real examples of studies that I'm working on the design with some collaborators with, just so you can sort of see how this plays out. And also one of them I'm not thinking of using MRP with. So that's kind of like an interesting distinction as well. Okay, so the first one I want to tell you about is using Amazon Mechanical Turk to study gender bias in authors. So this is joint work with Alan Riddle, who's at the University of Indiana. And basically, Alan is very interested in whether
It looks like we've lost the connection, and I think we've lost Lauren as well. So
I'll send her a quick email. Oh, maybe Winky just said maybe she has only the 40-minute Zoom.
I don't think that's it because it's been set up on a university Zoom account. So I doubt that's it.
Probably just dropped out. But let's see if, yeah.
Sorry, one standby.
Yeah, yeah. All right, who knows? I'm sure she's frantically doing all the obvious things. Yeah. Oh, she's in the waiting room. I just let her in. Yeah. I know. A cliffhanger. She did this on purpose, didn't she? Yeah.
We've got you again, Lauren.
Got you?
I like to have a bit of a cliffhanger. I'm so sorry, my internet dropped out.
Yeah. It added to the suspension, so good. Yeah.
Where did it drop out? Because I just noticed that it did.
You were about yeah, you had just described the first 2 dot points, I think, of that. Yeah.
Thank you. Sorry. I'm so sorry about that. Yeah, all good. Okay, so basically we're designing a study where we randomize, gendered author names and give participants a blurbs from basically lists of like various books that publishers can purchase. Alan's really cool. He has all of this stuff. And we ask them what they think about it on a bunch of different metrics, and we basically flip the gender of the perceived gender of the author name. Right, classic CD study, okay? Except we expect, we're fairly sure from previous work, there's gonna be a difference between the effects of men answering and the effects of women answering. So women apparently tend to be much harsher on women. And so other survey work has sort of suggested this. On top of that, we suspect from the literature that there will be age effects, reading effects, so your reading habits, and education effects, right? And so we've already planned, so this is a study that we're actually designing, we haven't got data yet, but we're planning to ask demographic questions on these. And we've spent a lot of time thinking about what heterogeneity to expect and how we can adjust for it, and making sure we measure it in ways that allow us to map really easy to larger surveys. So for example, we're using a large survey, the PIAC, large surveys of reading habits, to adjust our survey respondents so they're kind of representative US respondents when it comes to reading. So we've we've thought a lot about this because we want the results to generalize, right? On the other hand, my collaborators Nick Tierney and Adam Sparks and I are interested in how non-experts use maps, right? This is statisticians going, well, how can we communicate statistics a little bit better? And so they're really interested in the effect of color scale on reading and understanding maps that are both well-known and unknown. So, you know, a map of Australia is well-known, a map of just a random blob is unknown, right? And so here, well, we really just have a pilot study. There's not a lot of literature on this already. So kind of ideally, we want the sample to be quite homogeneous, right? For our question is there an effective color scale? And we want them to be non-expert. We don't want them to be trained on maps. We have absolutely no plan to use MRP because the question is there an effect of this manipulation? If there is, we'll look into heterogeneity later. And because of that, the psych undergraduate pool are perfect, right? Because they match the population that we're really interested in specific ways, right? They are not trained to read maps in their courses. They're generally literate and have normal or corrected to normal vision, and we can, you know, ask them on that. But they probably haven't been trained in how to use color scales to make plots, or maybe Andy does in her classes, in his classes. But you know, they're generally undertrained, right? So takeaways, what can we take away from all this? Because I've kind of told you it's important and then told you it's not important, right? It's kind of confusing. And so I think that's kind of the takeaway, right? It's not always possible. It's not always necessary. For example, if the question is there an effect ever? And you observe an effect, that's good enough. The question is answered, yes. Yes, there is an effect sometimes. If the question is there an effect ever? And you don't observe an effect, however, you can't kind of conclusively say there's not an effect, right? And then the same side, the flip side, if the question is there not an effect ever? And you observe an effect, that's kind of enough evidence to refute, right? But if the question is there not an effect ever? And you don't observe an effect, you can't say like for all people there is not an effect, right? On the other hand, it's kind of sometimes useful, right? But we need to be really clear about what our population is and about who we're really interested in researching. And we need to think about heterogeneity and potential interactions, right? And I think the sampling methodology kind of needs to reflect this. So if we're in this world, I think MRP might be a useful approach for non-probability samples. And these are the samples we use in psychology. We call them convenient samples, they're non-probability samples, right? Oops. That said, there's still lots of research to be done, and I hope you all will be excited enough after this talk to sort of think about it a little bit more in your research as well. Some of the stuff I'm working on currently, comparisons with other causal techniques like BART. Thinking about what we adjust to beyond demographics, and I think psychology is super exciting for this, right? Because if you're doing survey research, you might want to just adjust for the standard demographics, but if you're doing psychological research, maybe like age group and education level, maybe they're not what we want to summarize our population by, you know? Maybe we want to summarize them by personality or by something else, right? Kind of interesting. I think because of that, we're gonna at some point want to adjust for things that we don't know in the population. And then there's this whole question about whether it's better to do some adjustment versus no adjustment, right? And then there's like this design question, which I think is just super fun. Like, how can we design studies that consider potential sample heterogeneity? And I've sort of talked through a couple of examples of studies that I'm actively designing. One where I think about potential sample heterogeneity and it's really important. And another where I've thought about sample heterogeneity, it's quite important not to have it, right? So that's it for me. I think there's a few minutes left for questions, but thank you so much for having me as well. It's been really lovely. I guess I should end my stop screen sharing. I can look at how.
Cool. Thank you, Lauren. That was great. You have lots of applause. I don't know if you can see everyone's giving you little applauses. But but yeah, so we have about whatever 5 to 10 minutes for questions. So go ahead and just, I guess, speak up if you have one.
So can I ask another question?
Oh, yeah.
So could you say a bit about how Mr. P fits into sort of the literature that came before on hierarchical Bayesian models? Is it the post-stratification part that's different from what statisticians were doing at the time, or?
Yeah, I mean, multi-level models are pretty common, right? The difference is we normally use them to talk about like schools, right? Students within schools, right? You put a random effect for that, or schools within districts, you put a random effect for that. Now we're using them to regularize, right? So putting a random effect on age group, right? Because it pulls in a little bit. So that's kind of like one thing. More generally within the survey literature, there's these sort of folks who've sort of been working on this already. They've done models like the Fay-Harriott model, which is putting a random effect essentially on geography. And this kind of extends it and combines it with another pretty well-established method, which is the idea of post-stratification. So for example, post-stratification, if you're just looking at weights, what you do is you kind of get your weighted estimates for each cell of the number of people, and you basically tinker with the weights. That's a terribly not professional term, but essentially change them a little bit until they add up to the population totals, right? And that's kind of post-stratification, right? And so what MRP does is it kind of combines these two ideas together in a really neat way. And sort of as I've been working on it and thinking about it, I've really been thinking about how it fits into this like wider literature. I think it's like Rubin's sort of like framework of like thinking about things in terms of predicting, right? And you sort of see this with the causal literature as well. I think you sort of see, like there's the folks who do BART and regression trees and things like that, and they're thinking about predicting onto a new sample or predicting treated onto control, you know, that sort of thing. It's framed in this prediction sort of framework. But there's also, you know, the causal inference where you start thinking about propensity weighting, right? Where you try and make your control group look like your treatment group, right? And you give them weights to kind of adjust them back and forth, right? So it's almost like you start to see these problems get mirrored over and over again. It's super interesting.
Okay, thank you.
So I have a question as well, and I'm not sure it's a particularly well-formed question, so I hope you can get something out of my gibberish. But sort of thinking about, I'm basically thinking about the problem of sparsity. So say you have lots of different demographics, and then those demographics conditional on all the combinations of each other's, you can get really, really, you know, sparse samples in your data. And also, it feels, my intuition then is that basically then your model is going to be doing quite a lot of work there for you. And also, what if you don't have a model for like all the different kinds of subsets of things? Like, what do you do? Is that just a time you shouldn't use MRP, or yeah?
Yeah, I think one of the interesting things is like, we are kind of walking into this like field of extrapolation, right? And like, I'm so sorry, my cat is like making a lot of noise in the background. I hope you can't hear it. I'll just ignore.
Cats are great.
So you kind of have this like, on one hand, you're extrapolating, you're using the model assumptions to do that. So you're using assumptions of additivity, right? That the effect of being low educated and being female is the same as the effect of being educated plus the effect of being female, right? And there are papers where they've sort of put more interactions in, and then you have, she's just left. Every time I've tried to pick her up for the Zoom, she normally likes to cuddle, but she refuses to be on Zoom.
Right. So everyone has to listen to the answer to my question instead of look at a cat. I'm sorry.
Yeah. But so you're making quite strong assumptions, and I think people try and push those assumptions with different sorts of models, and they show that like oftentimes that works better. And I do this sort of research too, like it's useful to see how much of an effect it makes. But at the same point, like we are model reliant, and that's kind of the issue. So if you use weights, people will say you're doubly robust, like either the weights are correct or the model you're using the weights in is correct, and only one of them has to be true, right? That's a huge oversimplification of double robustness, but this is kind of the idea, right? Yeah. But when you're doing MRP and these sort of model-based or model-assisted work, you're model reliant, right? If your model's wrong, you can go really wrong, right? And so that's why we're working quite hard on, like, as we push it away from political science and start to get into more complex issues that we've used at estimating poverty and in biomedical science, you start to need to think more about what variables go in, what variables go out. And I think this is like the story of applied research, really. Like, the more you kind of apply it to new examples and you make it harder, like the more you start to push the method and explore it and understand it, which is kind of cool too, right?
Yeah.
Yeah.
Cool. That helps. Yeah. All right. So one more question, since we have no cat. Anyone have a last question? Yeah. Oh, hooray! Yeah.
There you go. And she's not thrilled with it, but there you are.
Hi, kitty. Okay, so that actually seems like a good stopping point, unless there's anyone. Yes, thank you, Lauren. That was really interesting. And Lauren is right down the street. Well, once we're back at Monash, so yeah, hopefully we'll have more dialogue with you. Thank you.
Yeah, no, thanks for having me. It's been great. And anyone wants to chat more about it, feel free to shoot me an email.
Cool. Thanks.
Thanks, Lauren.
All right.
Thank you so much.
Cheers.
Have one.